Here's a typical problem. Car starts at 15 meters and has a velocity of 7 meters per second. Car 2 starts at 133 meter mark and heads towards car 1 with a velocity of negative 9 meters per second. Where and when do the cars meet? Of course, as always, this is the key right here. Your final position of car 1 is equal to the final position of car 2. Now remember, this equation is equal to the position time equation we've been using over the last few days. So the position time equation for car 1 is equal to the position time equation for car 2. All we have to do is fill in the numbers. Recall, the initial position of car 1 was 15 meters plus its velocity times time is equal to the position of car number 2 at the beginning, which was 133 meters, plus its velocity, which was negative 9 meters per second, times time. Now we just have to arrange this. I like the idea of subtracting 15 meters from 133. It gives me a positive number. So I'm going to subtract 15 meters from each side. Once again, basic algebra. 15 meters cancel out on the left, and I land up with 118 meters on the right. Let me shrink all this stuff out of the way. Excuse me as I resize this so you can see. And once again, here's our equation that we're still finishing up. Now let's let's add positive 9 meters per second to each side. If we add positive 9 meters to each side, this will cancel out. Now why did I do this? Because meters per second times time, meters per second times time, they have that in common, so you can actually add those or subtract those. Okay, our 9 meters per second times time disappears on the right. Everything's on the left. 7 plus 9 is 16 meters per second times time. Now don't forget, time is our variable, not meters per second. Meters per second is just units. So 16 meters per second, let's divide that out from each side so I can get time all by itself. So 118 meters divided by 16 meters per second. The cool thing is the meters cancel. Look at that. The meters just canceled. Seconds moves up to the top. I have happy units. I'm looking for time, and my units is in seconds, so that's great. I know I did the problem right. And the answer is 7.34 seconds. That's how long it takes for the two cars to collide. So nothing happens for the first 6 seconds, and at 7.34, bam, they collided with each other. Let me move this out of the way. Now we want to know, where do they bump into each other? Where's the common place that they bump in? Well, they, just go back to the position time equation. Now we know when it occurs. So let's just push this back, or put this back into this part of the equation here. So now we know this guy, and this guy. We can solve for the position final of car 1. Now we could have solved this for position final of car 2. It wouldn't have made any difference. You're still going to get the same number. Once again, 7 times 7.34 is 51.4. So where do these cars bang into each other? At 66.4 on the X position line, I guess you'd call it.